Hi guys, this is our performance task in grade 10 third quarter. So first, it's all related to permutation and combination. First, let's explain or tackle about permutation. So what is permutation? Permutation is the arrangement of objects in which order is important. So here are the formulas of the three kinds of permutation. First is permutation of n object taken r at a time. Formula: npr is equal to n factorial over n minus r factorial. Second is circular permutation. Formula: p is equal to n minus 1 factorial. Third, distinguishable permutation. Formula: p is equal to n factorial over n first times n second factorial times n third factorial and so on.
Guys, this is an example of permutation of n object taken r at a time. Example, if there are 10 people and 6 chairs are available, how many ways can be seated? Our n is 10 and our r is 6. Solution, npr is equal to n factorial over n minus r factorial. So we have our n is 10 factorial and our r is 6. So we put there on 10 minus 6 is 10 minus 6 factorial. So we have 10 times 9 times 8 times 7 times 6 times 5 times 4. And result of 10 minus 6 is 4. We have 4 times 3 times 2 times 1. So we eliminate a 4. So the result of 10 times 9 times 8 times 7 times 6 times 5 is 151,200.
Second example, circular permutation. Number 2. In how many ways can 9 teachers be seated around a circular table? Solution, p is equal to n minus 1 factorial. Our n in this is 9 teachers. 9 minus 1 factorial is equal to 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 40,320 ways. Our third example, in how many ways can 5 keys be arranged on a key ring? Solution, p is equal to n minus 1 factorial. Our n for this is 5 keys. 5 minus 1 factorial is equal to 4 factorial. 4 times 3 times 2 times 1 is equal to 24 ways.
The second is combination. What is combination?
Okay.
A combination is an arrangement of n object with no repetition and the order is not important. Remember, the order is not important. The formula: NCR n factorial over n minus r factorial and r factorial.
Here are the problem example of combination. First, formula of combination. In how many ways can a principal choose 3 of their 30 teachers to attend a conference abroad? We have n30 and r3, and combination equal 30 factorial over 3 factorial, then 30 factorial minus 3 factorial. That 30 factorial use 30 times 29 times 28 times 27, then 3 factorial 6, then 30 minus 3 becomes 7. 27 and we will eliminate the same number. Then the result of 30 times 29 times 28 will become 24,360. Then the 3 factorial
6 will copy the 6, then 24,360 divided to 6 will become 4,060 ways.
The third example of combination. How many committees of 4 persons can be chosen from a group of 10 persons? The N is 10, the R is 4. Combination equals 10 factorial over 4 factorial, open parenthesis, 10 minus 4, close parenthesis, factorial, equals 10 factorial over 4 minus 4 factorials times 6 factorials equals the 10 factorial result is the 3,628,800 over the result of 4 factorial times 6 factorial is 17,280. So we divide the 3,628,800. So that to 17,280. So the result is 210.
Third example of combination. 6 officers of the mathematics class are in a conference room. Each are shake hands and with each of the other. How many handshakes are possible? N or 6 and R 2. 6 C2 equals 6 factorial and 2 factorial. 6 minus 2 factorial equals 6 factorial. 2 factorial, 4 factorial equals 30 over 2 equals 15 handshakes.
Fourth example in combination. Trevor has 12 books on his summer reading list. He wants to choose 3 books to read over the summer. In how many ways can he choose the book? Solution: 12C3 equals 12 factorial over 12 minus 3 factorial and 3 factorial. So the result of 12 minus 3 is equals to 9. So we copy that 3 factorial and put there. So the result of 12 factorial is 479,000,000 and 1,600. Then the result of 9 factorial times 3 factorial is 2,177,280. So we divide these numbers into 479,000,000 and 1,600 to 2,177,880. So the result is 220 ways. Fifth example in combination. A player chooses 6 numbers from 1 to 42 in no order. How many possible bets are there? So solution: 42C 6 equals to 42 factorial over 42 minus 6 and 6 factorial. So we evaluate 42 factorial, and 42 times 41 times 40 times 39 times 38 times 37, and we just end to 36 because the result of 42 minus 6 is 36. So we eliminate same number because 36 and to lower is just the same, so we eliminate 36 only. Shortcut, guys. So we copy 6 factorial and put it right here. So the result of 42 times 41 times 40 times 39 times 38 times 37 is 776,965,920, and the result of 6 factorial are 720. So we divide it the 3,776,965,920 divided by 720. So the result are 5,245,786 bets.
Example number 1. Find the number of different ways of placing 4 marbles in a row, given that 3 are red, 2 are green, 2 yellow, and 1 is black. Given n equals 4, n1 equals 3, n2 equals 2, n3 equals 2, nk equals 1. Given n equals 4, n1 equals 3, n2 equals 2, n3 equals 2, nk equals 1. Formula: p equals n factorial over n1 factorial times n2 factorial times n3 factorial times nk factorial equals 4 factorial over 3 factorial times 2 factorial times 2 factorial times 1 factorial. The result of 4 factorial is 24, and the result of 3 factorial times 2 factorial times 2 factorial times 1 is equal to 24. So we divide so we divide 24 we
We get 1.